My name is Todd Kloots, a member of the core team here at Yahoo that works on YUI. And this afternoon I'm going to walk you through some of the sugar that we've made available to you in YUI 3. I thought this would be a nice slide to start today's talk off with. This was back from the front-end conference we held here at Yahoo in 2007. And I think towards the conclusion of the conference we had all this leftover candy that someone had shaped into the YUI logo. And so I thought it was an appropriate beginning to today's talk. So since we're towards the end of day 2, you're probably already now familiar with getting YUI 3 on the page. And what I wanted to talk about first was if you set up your YUI sandbox and you use the use statement, but you don't specify any additional modules, so you're just working with the very core of YUI 3, there's actually some sugar there we can start talking about that's really useful, and so that's where I wanted to start us off with, which is just the sugar that's available in the YUI 3 core. So let's delve in and look at what some of that sugar is. So again, if this is how you structure your use callback, we're not going to request any additional modules to start. We're just going to use the core. Within the scope of our callback function, our YUI instance will have some of these modules and methods. And let's start with y.log. Y.log, very simple piece of sugar, which is a single interface into logging to the console of whatever particular browser that you're working with. And I believe at this point, the latest version of all of the A-grade browsers, as we think of them here at Yahoo, has some sort of console that you can log to. But just in case you're working with a browser, an older browser perhaps like IE6, and you want to be able to log to a console, of course we have a console widget that is available to you. And by specifying console in the use statement and using these 2 additional lines of JavaScript, you can now have a console available to you that you'll be able to log to. Something that pairs nicely with log is y.dump, and you can get dump also via the use statement, just like you can get any additional module added to your sandbox. So I'll specify dump via use. And y.dump simply stringifies an object. And so this is a very nice piece of sugar for doing some simple object introspection. So I have this object by the name of my object. I'm going to pass it to y.dump. It's going to stringify that object. I'm going to pass the result of that to y.log. And if I look at the console, for example, in Safari, this is what the output of that object, my object, is going to be. And so as you can see, the properties and methods of my object are nicely stringified in the console log. So just an additional tiny piece of sugar that you can take advantage of. The core also includes y.later, and this is a nice interface to both set timeout and set interval. And the nice piece of sugar that later adds is the ability to call a function with a different context. So I have this instance of Gizmo and has a foo method that I want to call via set timeout, and I can use later to do that really easily. So I'll call y.later. Its signature is first and foremost the milliseconds that I want to call this function with, followed by the context that I want to call this function with, and then finally the function. So in this case, I'll be using the foo method of Gizmo, and that essentially ensures that Gizmo's foo will be called within the context of Gizmo. Another additional piece of sugar that later brings to the table is it returns you an object with a cancel method. So canceling your timer is easy as essentially just calling a cancel method. If you want to call your function with arguments, you can construct an arguments array that you pass as the 4th argument to later. And then your function will be called with those arguments in the order that they're received in that array. So in this case, I'm going to be calling Gizmo's foo, specifying the arguments as 1 and 2, and later we'll ensure that they're executed like that. And then the final argument to later is a Boolean that specifies whether or not this should be a set interval versus a set timeout. So in this case, I want to call Gizmo's foo every 50 milliseconds, and so I'll specify true to do that. Now I'm doing this on an interval basis. And regardless of whether I'm using set timeout or set interval, I'll always be returned that timer object with that cancel method to cancel the timer. And that's y.later. You also get y.cached, and y.cached is really handy in that y.cache allows you to cache the results of a function. And this is useful when you have a function, for example, like I had this function foo, and I know that if I call foo with a certain set of arguments, that foo is always going to return the exact same result. And so what foo will do is return me a wrapped function that can now do caching. And so if I call foo, if I call my now caching version of foo with args 1 and 2, the first time it's called, foo will execute. The result of that function will be cached, and then that result will be returned. The second time I call the cache version of that function foo with the same arguments, I'm now going to get the result immediately. The original foo will not be called at all. So I'm just going to be returning the value as it was cached the first time. And one implementation of cache that we use actually is another piece of sugar that we provide within YUI3, which is this utility called the class name manager. And this, if you went to Satyen's talk on widget, this will seem a little bit familiar to you. We use the class name manager to generate state-based class names for widgets, for example. So if I have a button and I want to generate a class name that is representative of that button's hover state, I can use class name manager to do that. So I'll pass in these two strings, button and hover, and class name manager will generate me a prefix comma delimited string representative of that state. And subsequent calls to get class name with that exact same set of arguments will return me the cached version of that initial call. So that way I don't have to, it's not doing that string concatenation every time. It's just returning the result straight away. And so this is a nice example of sugar built on top of sugar available to you in YUI3. Yes?
Can you control the namespace?
Yes, you can. Mm-hmm. Another really nice module available to you in the core of YUI3 is this user agent module. And of course, this is really handy for simple user agent detection. It is, for example, if we wanted to detect the version number of the Gecko browser, we would be able to do that via y.ua.gecko, and that's going to return the version number. And if we're not in a Gecko-based browser, it's going to return 0. As will any of the properties, and so this is also handy for falsy checks. And you can also detect the operating system. This is currently limited to Mac and Windows, so it'll return Macintosh or Windows based on the operating system. It'll detect HTTP versus HTTPS via UA Secure. We've also gone beyond getting the ability to detect the big screen browsers, and we've started to target mobile browsers as well, and so you can use y.ua.mobile to detect what is currently a subset of the mobile browsers, for example, Safari on the iPhone or Opera Mini, and I believe WebKit on Nokia's N95. Those are the browsers currently supported by UA.mobile. And we've also given you the ability to detect other browser-based environments, such as Adobe Air, so that'll return you the Adobe Air version. And if you're working with Caja, you can retrieve the Caja version also via UA simply by querying y.ua.caja. There's also y.lang, and this is a nice module that encapsulates type detection. So if you have an object and you want to detect or check if this is a string, you can pass that to y.lang.isString. There's similarly is undefined, is null, is array, etc., etc. If you have an object and you want to find out what the type is explicitly, you can pass that to y.lang.type, and it'll return you a string representative of the type of that object. And lang is also where you'll find our trim method for strings. So this is what we covered so far. There's some additional sugar in the core that I wanted to walk through with you, and that primarily targets working with objects and arrays. Y.array is really useful in that if you use you can use y.array to coerce any object into an array. We use this extensively actually throughout the YUI3 ecosystem. For example, to take the arguments object that is available within the scope of a function and actually coerce that into a real array that we need to then manipulate in some way. So y.array is very useful for that. And y.array also has a bunch of static methods available to you. A lot of them are going to be familiar because they mirror those found in JavaScript 1.6. So by default, you'll have a small subset of those array methods implemented in JavaScript 1.6. And the names mirror those JavaScript 1.6 array methods almost exactly, with the exception of each. So in JavaScript 1.6, it was for each, and we've just shortened that to each. But otherwise, they all carry the same name. And beyond those methods available in JavaScript 1.6, we also provide you with some additional sugar methods for working with arrays. And that's just in the core. If you include this additional submodule by the name of collections, your y.array module will be further augmented with additional abilities. And so augmenting with collection will give you the remainder of the array methods available in JavaScript 1.6, as well as the reduce method that was implemented in 1.8. And we'll also fill out an additional set of array sugar methods for you. So you have a whole bunch, a nice suite of array sugar methods to work with in YUI 3. And then there's also y.object. And y.object allows you to create a clone of an instance of an object that you already have. And so what y.object will do is take the prototype of the object that you pass it, create a new object based on that prototype, and then return you that instance. And y.object also has a bunch of static methods on it for making working with objects a little bit easier. For example, there's an each for iterating all the properties of an object, as well as two useful methods, I think, such as keys and values for returning all the keys or values of all the properties of an object. The core also includes a nice utility for creating mix-ins, and this is a nice pattern for code reuse, and JavaScript's expressive power makes it really easy to create mix-ins, and we've tried to make y.mix allow you to do mix-ins even easier. And so one simple use case might be that I have these two objects, object 1 and object 2, and I want my object 1 to have some of the functionality that object 2 has, and so I can achieve that through y.mix. And what mix does is it copies values from the sender to the receiver, both values that are static values and prototype values. So when I call y.mix on object 1 and object 2, bar and baz from 2 will be copied onto object 1. You'll notice that the name property that these both of these objects share remained the same on object 1. And that's because by default mix, if there are duplicate values on both the sender and the receiver's value is preserved. It's only new values from the sender that get copied over to the receiver.
Does it return anything?
Mix does not return anything. No, it just augments the receiver. Mm-hmm. And there's a lot of additional power to mix. And so what we've done is we've built some additional sugar methods on top of mix that target a lot of use cases, or common use cases rather, that we've encountered throughout our own ecosystem in YUI 3, and those that we think that will also be very useful to you. And one is merging data sets together, and you can do that really easily with y.merge. So in this case, I have 3 different objects, and I want to merge them all together into a new object, and merge allows me to do that really easily. So I'll pass all these objects to merge, and what merge will do is create me a new object, and it'll start copying these values into it. And what merge does is, unlike mix, values from later objects overwrite values from earlier objects. So if we walk through what merge will do here, it'll first take the name value, the name property from object 1, and then it'll know that both object 1 and object 2 share this foo property, but because object 2 occurs later, object 2's foo will win and get copied over into the new object. Similarly with bar with object 2 and object 3. So object 3's bar, because object 3 occurs later, will win out over object 2's. And finally, baz is unique to object 3 in this case, so it will also get copied over. And so that new object containing all those properties will be returned to us from our call to merge. Merge can also be used to create a shallow clone of an object that you have. And so in this case, I have object 1. I'm going to pass that to merge, and what merge is going to do is create a shallow clone insofar as the name and bar property will be copied over. And then because foo is a property that represents an object, the clone will that we get back will have a foo property that essentially just references the foo on object 1. So that will just create a shallow clone using merge. if you include this additional module by the name of OOP, you'll get some additional functionality for working with objects. And if merge allows you to create a shallow clone of an object, clone is your go-to for creating a deep clone of an object. So in this case, we'll pass object 1 to clone. Clone will create a new object, and it'll have it'll have a copy of all the values from object 1, none of which reference object 1. They're all now protected and unique to that clone. There's also aggregate, and what aggregate does is copies values from the sender to the receiver. If the receiver and the sender have a property of the same name, those values are combined if they're an object. So in this case, 2 and 1 have the same property foo. And so what it'll do is when it's aggregating these two objects, foo's values, the value of foo will get merged with the value of foo on object 1, so that the result of object 1 will be foo with subproperty values of foo 1, foo 2, and foo 3, and then bar, not being an object, will just be its value will be copied over into object 1, and so the result will be object 1 with the values from the sender. Then there's y.augment, and augment is really great insofar as augment allows you to borrow functionality from one class and apply it to your new class. So in this case, I have two classes, Gizmo and Doodad, and my Gizmo class, I really like it, but I wanted to borrow some of the functionality from Doodad, and so what augment does is it copies values from the prototype on the sender to the receiver. But it does something else that's really cool. It's very likely that Doodad's constructor is going to be responsible for some sort of state setup. And so the first time that I call bar, for example, or baz, the first time I call one of the methods I copied over from Doodad on my Gizmo, it's actually going to invoke Doodad's constructor. And then it's going to call bar. So that all the state management was required for a Doodad instance that is responsible, that the constructor was responsible for doing, is properly set up, and then bar is called. If I then call baz, it's just going to call baz directly now. Since the state of Doodad is now properly set up. So that's what augment does. Augment is a prototype to prototype copy and allows you to mix and match functionality across classes. But you can also do this on an instance. So if I now have an instance of my Gizmo, I can augment it with Doodad's functionality, just as I would if Gizmo was a class. And the same rules apply. The first time I call bar, for example, Doodad's constructor is going to get invoked, and then bar will get called. And then finally, there's extend, and extend gives you everything you need to do standard prototype-based inheritance. And so if I have a Gizmo class that I want to extend with Doodad, essentially what I'll do is I'll call extend, passing in Gizmo and Doodad, and then that will create a new property, superclass, on my Gizmo class, and that will have a constructor property that points back to Doodad's constructor, and then it'll also copy in values from the prototype of Doodad. And so now Gizmo has inherited from Doodad, and in my constructor of Gizmo, I can now properly chain that so it can call back up to its superclass. And so that's y.extend. So here is the full summary of the suite of sugar methods for your use for composing objects. Remember that y.object, mix, and merge are part of that core package, and aggregate, clone, augment, and extend are part of the OOP module, which is an optional request. So just to review again, a subset of this functionality is available in the core, and then the full suite is available via OOP. There's some additional functionality in OOP that's really cool. One is a generic each, and the generic each allows you to iterate objects, arrays, and node lists. And the function that you supply to each will receive two arguments, the value and the key of whatever object you're iterating. And you can even change the context of your function by passing that context as the third argument to each when you're setting up your iteration. So in this case, the This object will always reference object 2. And then YBind, this is something that I believe is part of ES5, and so this has been also implemented in YUI3. This allows you to change the execution context of a function. So calling y.bind on foo will return us a wrap function so that when we call the bound foo, the default context will now be bar. Beyond the core, if you include the node module, node, of course, is our single interface for operating with the DOM in YUI3. And in addition to providing you with all the standard DOM API methods and properties that you'd be expecting, we also supplied a bunch of sugar that I'd like to tell you about. So one of the things we try to do to make your life a lot easier in YUI3 falls within the scope of node creation. And so this is your standard W3C node creation code snippet for creating a checkbox, for example. So I'm going to rely on create element, and then I'm going to have to add the additional properties after I get a reference back to that node created through create element. And in YUI3, you can do this all in one go simply by specifying your element as a string of HTML that you want created, call y.node.create, pass in that string. It's going to create that node instance for you and return it to you. But very often, you don't want to just create one node instance. You want to create a bunch of them. And so you can pass an entire document fragment to y.node.create. And so in this case, I'm not just creating one checkbox, but I'm creating a div that wraps several. I can call y.node.create, pass in that whole string, and I'm going to get a reference back to that document fragment. But of course, I don't just want to create nodes. I want to put them into the DOM. That's kind of the obvious next step. And so we allow you to kind of do all of that in one statement as well through through nodes append methods. So in this case, I'm not only creating this series of elements on the fly, but I'm also appending them all at the same time. So this essentially creates power under the hood with the additional append. So it kind of targets that use case that you're going to want to create something and put it in the DOM right away. There's also a prepend method, so whereas append will make whatever you call the last child of that node that you specify, prepend will make it now the first child. And these methods actually work really nicely with a piece of string substitution sugar that we provide you with in YUI3 in the form of y.substitute. And so substitute is something that we can use, for example, with append. Let's say we have this definition list and we have this object that contains a bunch of terms and definitions. We want to create a template that we can use to populate with the values that are stored in this definitions object. So what we'll do is we'll set up our template, and what substitute relies on is placeholders defined by curly braces. So in this case, our template's going to reserve placeholders for terms and definitions, and then we're going to get a reference to our node that we want to append this new HTML into. And we're going to use each to iterate our definitions object. And what we're going to do is we're going to call substitute, pass in our template, and then substitute's second argument is an object literal that whose property names refer to the placeholders that we've specified in our template. So this way we can, in one go, substitute in the strings that we need and then append those into the DOM. And so a really nice, easy way to set up templating within your application. Node also has an insert method, which has a lot of power insofar as giving you the ability to do things just... I'm sorry, you had a question?
I said, yay.
Oh, okay. Sorry. I thought I saw a hand.
Thank you.
So what insert allows you to do, just like append, is create an element, but insert it either based on a reference to an index into the child node collection for that node, or another node in that document structure that you know about, or before and after, obviously. So a lot of different power available to you for inserting something into the subtree of another node via node's insert method. We've also tried to make removing elements from the DOM just a little bit easier. So in standard DOM, you always need a reference to your parent node before you can remove it. And so once I have a reference to my parent, I can call remove child, and then I can remove. But in YUI3, we try to make that as simple as possible by just giving you a remove method. So if you have a node reference, you can just call remove, and that element is now gone. Similarly, to replace a node in the DOM, we try to make it just as easy. So again, standard DOM, you need a reference to your parent. With YUI3, you have a node reference. You can call replace, specify the node you want to replace that node with, and it just does the replacement for you. We've also tried to make navigating the DOM tree a little bit easier. By default, in the W3C DOM implementation, you have these next previous sibling methods. These can occasionally trip you up insofar as you might actually receive a reference to a text node that is the next sibling or previous sibling of an element, and that's a lot of times undesirable. What you really want is a reference to the next element. And so we give you next and previous as a nice, concise way of retrieving those references. So you can navigate your siblings, the siblings that you're really interested in those element siblings really easily with next and previous.
So no more text node, right?
No more, not unless you want them. Because we preserve the standard DOM API insofar as next and previous. You still have access to those, but if what you're really interested in are the element nodes, next and previous give you what you want. We also give you ancestor as an easier means of climbing up your ancestry hierarchy. So if I'm currently at list item 3 and I want to get back up to a given ancestor, perhaps an element that I've designated with this class name root, I can use CSS selector syntax to then go traverse back up the node hierarchy simply by calling the ancestor method on my node instance, specifying that class name, and now I'll retrieve a reference back to that root UL. So really nice compact syntax for getting at some point in the in your ancestry. It doesn't need a class. It's a CSS-based selector that you can use. So that can be any selector that's designed to target one of your ancestors.
It's easier than using XPath.
Yeah, I hope so. I'm not super familiar with XPath, but yeah. There's also set content, and we like to think of this as a safer version of inner HTML. One of the things that is slightly unsafe about inner HTML is if you're using inner HTML to replace a subtree of a given node, and somewhere else in your application logic you have references to nodes within that subtree that you're replacing, the minute you call inner HTML, those node references that other pieces of your application have references to are now erased. And so if you want to do some sort of subtree replacement, set content is probably a nicer method for you to use insofar as what set content does is removes all the immediate descendants of the node that you specify, so that, and it does that just by calling remove child, so those node references are still in memory. And so if you need to do your own cleanup, you still have the ability to do so because those node references are preserved within the scope of your application. But then, you can still have the power of inner HTML for then adding the new markup into the document. Another nice piece of set content's value proposition is the fact that it caches the nodes that are created by it. So essentially uses the string that you provided as part of your template as the lookup into the cache that it provides. So subsequent calls to set content with the exact same string will result in a clone as opposed to recreating that same node. And of course, YUI3 also facilitates chaining of node methods where they make sense. And so if you go through the node API, any method that is chainable is actually designated as such in the API docs. So in this case, I'm not only going to create some checkboxes that I'm going to append to my form, but then I'm going to iterate all those input elements and add a class to them, kind of all in one chained expression. The node list interface also provides you with some nice sugar methods for filtering and iterating node lists. So if you have a node list you want to further refine, you can use filter to do that. Filter accepts a CSS selector that you can use to further refine that node list. We also have odd and even for obviously doing exactly what the name says, returning the odd and even items in that node list. And then you have each and some for doing iteration, some giving you the ability to break out of a loop. Then the final piece of sugar I want to talk to you about today was all the sugar that we've added into YUI3's event library. So Eric covered this in the keynote of day one in that in YUI3 we've introduced this event facade. So all your event listeners, the event object reference that you get back is a facade. This allows us to not only implement the standard DOM interface for events, but allows us to easily add in sugar methods such as halt, which calls both prevent, default, and stop propagation. We've also added additional custom events that give you an easier way of working with the DOM. For example, one of the core principles of DOM scripting is you can't script what has not yet been parsed and loaded by the browser and is available in the DOM tree. And so you can use available content ready and DOM ready to listen for when is the right time to start scripting a certain piece of the DOM. And that script can actually live or precede the portion of HTML that you're interested in scripting. So in the case, for example, one use case for content ready would be, I'm interested in doing something to this to the subtree of this node main as soon as it's available for scripting, and I can have that script block that's responsible for executing that code actually precede main using content ready. So content ready will not only pull for when that element is accessible in the DOM tree, but when that element's entire subtree is ready to be scripted. And the really cool thing about Y.on is it also has built-in unavailable knowledge. So you can wire up event listeners to elements that will be loaded further on in the document. So in this case, I've bound a click event listener to a button before the markup for that button has actually been partially loaded by the browser. The default behavior for Y.on is if it doesn't find the object that you're trying to bind an event listener to straight away, then it will start polling. I think the default is 30 seconds is the poll. We've also tried to supplement the DOM events that are available to you in the browser natively, and also make events that are available to you in the browser better. On the later point, making existing browser events better would be focus and blur. So those are two events that don't bubble by default in the browser, and they do in YUI3 when you're adding focus and blur event listeners. Those events do bubble. We've also added useful events such as mouse enter and mouse leave. These are, if you're familiar with Internet Explorer, these have been in Internet Explorer for a long time, I believe, since IE5. And these are essentially non-bubbling versions of mouse over and mouse out. And one simple use case for something like mouse leave would be a drop-down menu. And here's my mouse pointer. I want to hide a submenu when the mouse leaves the scope of that menu. And in this case, mouse out is giving me a little more information that I really need because of the bubbling nature of mouse out. I'm getting all the mouse out for all the children of that submenu. And what I really want to know is just tell me when the mouse has finally left that container. And so mouse leave is really nice event for doing something like that. So in this case, I'm now just going to log when the mouse has left that submenu. So I get one event that gives me exactly what I want. So mouse enter and mouse leave are really nice sugar methods. We've also made it really easy to do event delegation. So event delegation is a really popular pattern for making flexible and performant. It's a good pattern for flexible, performant event listeners. If I want to do something in native DOM as simple as add a click listener to a list that simply logs the inner HTML of one of these list items that's clicked on, that's the amount of standard DOM event code that I have to write to facilitate that seemingly simple logging of the inner HTML. And that's the amount of YUI3 code you need. And so we allow you to do this really easily through our delegate method that's available on every node instance that you have. So you can call delegate. First argument is an event that you're interested in delegating, followed by your event handler. And the third argument is a CSS selector that you can use to tell delegate, these are the elements that I'm actually interested in listening for this event on. And so this ensures that your handler will only be called when the target of that event matches that specified CSS selector. So in this case, I'm going to tell delegate, only let me know when the user clicks on an element, an LI that is a direct descendant of this list. And so an additional piece of sugar we give you is the default context of your handler is now that element that matched that CSS selector. And so it's always going to be the element that you're interested in as opposed to the container that you actually bound that event handler to. And in the event that you change the context of your event handler, either through y.bind or some additional arguments that are available to you via delegate, you can always get a reference back to the element that matched the CSS selector also via the current target property. And we also add an additional property to the event called container, and this is essentially the element that is a delegation container. This is the element to which you originally bound that delegated event handler. So you have properties that give you all the references that you need. We've also tried to make it as easy as possible for you to remove event handlers in YUI3. And what happens in YUI3 is when you use the on method of Node, it returns you a handle, and that handle has a detach method on it, and you can use that to detach that event handler whenever you need to. This makes it really easy, for example, to create an event listener that you only want to call once. Another way we've tried to make removal of event handlers really easy in YUI3 is by allowing you to subscribe to events with a prefix, which you can then use to detach those event handlers. So in this case, I want to bind the same event handler to a bunch of different elements of the DOM. I want to be able to remove them all in one go. And so I've used this prefix called set1, and the prefix is delimited from the event type via this pipe. And I'm going to subscribe to that click event on all those individual DOM elements through on using that prefix. Then I can call detach once, specifying that prefix in the event type, and it's going to detach the event handlers from all those given elements that the event was subscribed to with that prefix. So a really nice way to remove event handlers really easily. The final piece of sugar that I want to talk to you about today also comes with the event utility. And it's this module called do. And do essentially allows you to inject some logic into a function before or after it's called. And so if I have these two classes, doodad and gizmo, I also have this additional module called fx. And I create an instance of my gizmo, and I want to call fx's while method before gizmo's foo method is executed. I can do that really easily with before. So I call y.do.before. The first argument is the method I want to execute, or the function I want to execute rather. In this case, it's fx's while method. Then I'll pass in my gizmo instance, and then a string representative of the method on gizmo that I want to run this code before. The first time I execute my gizmo's foo, what it's going to do is call wow, and then it's going to call original foo. And similarly with after. So we will be executed before doodad's bar method.
Is it only the first time?
No, I'm sorry, I misspoke. So it'll be every time. This will allow you to interject this logic and yeah, yep. So that's all the YUI sugar that I wanted to talk to you about today. I'm happy to answer any additional questions. Otherwise, this is my contact information.